In this video, we will look at the second derivative. So the second derivative of a function is the derivative of the first derivative. So we basically differentiate the function twice. So if we have a function f of x, and then we differentiate this function with respect to x, we get the first derivative, f dash of x. And then if we differentiate f dash of x with respect to x, we get f double dash of x, which is the second derivative. So f double dash here, in this case, represents the second derivative of f of x. So for a function y equals f of x, if y dash represents the first derivative, y double dash represents the second derivative. If f dash of x represents the first derivative, f double dash of x represents the second derivative. If dy by dx represents the first derivative, then d2y by dx squared represents the second derivative. So let's look at an example. Find f double dash of x if f of x equals 5x cubed minus 2x squared plus 5. So to find the second derivative, we first need to find the first derivative. So to differentiate, so to find f dash of x, we use the simple rules of differentiation that we learned before. So the derivative of 5x cubed is 15x squared. And then the derivative of negative 2x squared is negative 4x. And the derivative of 5 is 0. So f dash of x is 15x squared minus 4x. And then to find f double dash, so f double dash of x, we differentiate a second time. So we apply the rules of differentiation here on f dash of x. So 15x squared, the derivative of 15x squared is 30x. And the derivative of negative 4x is negative 4. So the second derivative of this function is 30x minus 4. The question could go on and ask for f double dash of 3. So f double dash of 3 means we substitute 3 into f double dash. So f double dash of 3 is equal to 30 times 3 minus 4. So 30 times 3 is 90. 90 minus 4 is 86. So the value of the second derivative at 3 is 86. Let's look at another example. Find d2y by dx squared if y equals 2 bracket 3x minus 7 bracket all to the power of 5. So again, d2y by dx squared here is the second derivative. So we need to find the second derivative. But to differentiate, again, we need to find the first derivative first. Looking at this question here, we have a bracket raised to a power of 5. So in this case here, we will use the chain rule or the function of a function rule, the derivative of a function of a function. So remember that if we are differentiating a bracket raised to a power of n, so the derivative of f of x to the power of n is equal to n times f of x to the power of n minus 1 times the derivative of the function f of x, which is inside the bracket. So let's apply this rule to find dy by dx, or the first derivative. So dy by dx is equal to, now differentiating this here, 5 to the front, so 5 times 2 would be 10, so that would be 10 times 3x minus 7 to the power of 4 times the derivative of what's inside the bracket. The derivative of 3x minus 7 is 3. And then this can be simplified to 30 times 3x minus 7 to the power of 4. So this here is the first derivative. And then to find the second derivative, we apply the rules again. So d2y by dx squared is equal to, now 4 to the front, so that 4 times 30 is 120 times 3x minus 7 to the power of 3 times the derivative of what's inside the bracket is 3, which equals, so 3 times 120 is 360, so 360 times 3x minus 7 to the power of 3. So this here is the second derivative of this function that we started with. Another example, find y double dash if y equals 5x squared minus 7 all to the power of 3. So again, this is a bracket raised to a power, so to differentiate this we will have to use the function of a function rule. So to find the first derivative, y dash is equal to, the power is 3 times 5x squared minus 7 to the power of 2 times the derivative of what's inside the bracket. The derivative of 5x squared is 10x, and the derivative of 7 is 0. And again, this can be simplified to 30x times 5x squared minus 7 all to the power of 2. Now we need to differentiate a second time. We need to find y double dash. But if you look at this function here, now we have to use the product rule as we have two functions. So this here is a function, 30x, and multiplied by another function here, which is the bracket raised to the power of 2. So we'll have to consider the product rule. So as we learned before, to find the product rule, if I choose u to be the first function, so 30x, and v is the second function, which is 5x squared minus 7 all to the power of 2. U dash is the derivative of 30x is 30, and v dash is the derivative of this bracket, so we'll use the functional function rule again. So it's 2 times 5x squared minus 7 to the power of 1 times the derivative of what's inside the bracket, which is 10x, and this can be simplified to 20x times 5x squared minus 7. And then remember that the derivative would be u dash v plus v dash u. So in this case here, y double dash using the product rule would be 30 times this bracket, so 30 times 5x squared minus 7 all to the power of 2 plus v dash u, that is 20x 5x minus 7 times 30x. So if we multiply this, that we get 600x squared times 5x squared minus 7. And this here is the second derivative of this original function. Another example, find f double dash of x if f of x equals x plus 2 over 3x minus 5. As you can see here, this is a fraction, so we would be using the quotient rule. So using the quotient rule, if I choose u to be the numerator, which is x plus 2, and v is the denominator to be 3x minus 5. So u dash, the derivative of x plus 2 is 1, and the derivative of v, which is v dash, is 3. And again, remember the quotient rule is u dash v minus v dash u divided by v squared. So f dash of x, which is the first derivative, is u dash v. So that's 1 into this bracket, so that's 3x minus 5, minus 3 into this bracket, so that's 3 times x plus 2, over the denominator squared, which is 3x minus 5 whole squared. Before we differentiate a second time, it's better that we simplify this fraction. So if I expand the bracket in the numerator, so 3x minus 5 minus 3x minus 6 divided by 3x minus 5 all squared. And then the positive 3x and the negative 3x cancel each other out, and we get negative 5 minus 6 is negative 11 over 3x minus 5 whole squared. So this is the first derivative in its simplest form. Now we need to differentiate a second time. Now I have two options here. I could use the quotient rule again with the numerator and denominator, but actually it's easier to rewrite f dash of x as negative 11 times 3x minus 5 to the power of negative 2, and then differentiate using the function of a function rule. So f double dash of x is now negative 2 to the front times negative 11, that's 22, times 3x minus 5 to the power of negative 3 times the derivative of what's inside the bracket is 3. So in its simplest form, that would be 3 times 22 is 66 over 3x minus 5 to the power of 3. So this is here f double dash of x in its simplest form. 66 over 3x minus 5 all to the power of 3. Let's look at another example. This is our final example for this lesson. Find y double dash if y equals 2x over 3x squared plus 8. Again, we have a fraction here, so I'll use the quotient rule. So the numerator, so u is 2x, and v is the denominator, which is 3x squared plus 8. U dash, the derivative of 2x is 2. V dash, the derivative of 3x squared is 6x, and the derivative of 8 is 0. and the quotient rule is u dash v minus v dash u over v squared. So y dash, which is the first derivative, is equal to u dash v, so 2 into this bracket, so that would be 6x squared plus 16 minus 6x into 2x, so 6x times 2x is 12x squared over 3x squared plus 8 all to the power of 2. In the simplest form, that would be 16 minus 6x squared minus 12x squared, that's minus 6x squared over the same denominator here, which is 3x squared plus 8 all to the power of 2. So this here is y dash in the simplest form. Now to differentiate a second time, I could do what I did in the previous example, take this and raise it to the numerator with a negative power, but in this case here I will use the quotient rule a second time. So I'll again select the u and v. So u, the numerator, is 16 minus 6x squared, and v is the denominator, which is the bracket 3x squared plus 8 to the power of 2. So u dash is the derivative of this. The derivative of 16 is 0. The derivative of negative 6x squared is negative 12x. And v dash, the derivative of this bracket, so that would be 2 times the bracket 3x squared plus 8 to the power of 1 times the derivative of what's inside the bracket, which is 6x. So v dash in a simpler form, that would be 12x times 3x squared plus 8. And again, the derivative would be u dash v times v minus v dash u divided by v squared. So y double dash is u dash v, so that's negative 12x times 3x squared plus 8 all to the power of 2 minus u v dash, or v dash u, so that would be 12x times 3x squared plus 8 times 16 minus 6x squared over the denominator squared, which is 3x squared plus 8 all to the power of 2 squared, so that would be to the power of 4. So this is the second derivative here of the function. Now for practice, you could expand these brackets and simplify and get it to the simplest form. And you should find that in this case here, y double dash would be 36x cubed minus 288x over 3x squared plus 8 all to the power of 3. So I'll leave you to expand and simplify this and show that it reaches to this simplest form here. Normally in a test or an exam, you would be asked to find the first derivative, but there is no need to simplify your answer. But for practice, I'll leave you to show that the second derivative will be this.